I'm really, really looking forward to being part of this conversation. And this is my first time presenting in the Summer Learning Academy. So I want to thank Nova Scotia Department of Education for allowing me this opportunity. And we're going to talk about questioning in math. And this will be the first time that I've had this presentation as a standalone, because mostly I address the mathematically literate environment, but I've been thinking a lot about questioning, especially when we've had this disruption to the school year, when we've had to rely on online learning this past spring, and we're not quite sure what's happening in the fall. So I just wanted to hone in on the importance of our questioning and what we do in math class. And what I want to kind of preface during this is, I think we can dig deeper in making a bigger impact on student learning. And I'll kind of go through that as the session unfolds, because I think it's always important at any session I give. I want us to be put in the mindset of problem solvers, of mathematicians, the same way that our students are in the classroom. So I want you to try this. So David, I just went with that name because I thought it's a pretty good name. David divided 15 pennies among 4 small containers, and there's the containers at the bottom. He labeled each container with the number of pennies in it. He could then pay any sum of money from 1 penny to 15 pennies without opening any container. How many pennies did David put in each of the small containers? So regardless of the amount of money, anywhere from 1 penny to 15 pennies, David would not need to make change out of the jars. He could just give 1 or 2 or 3 or 4 jars to pay for an item from 1 penny to 15 pennies. How many pennies did David put in each small container? I want you to think about that, and I want you to try to work on that. How would you approach that?
We have one answer already, but I'll give freedom to some. I'll give you some wait time there. Let me know when you want me to let you know.
Okay. Now, here is when I think about how many people here have just kind of said, yeah, I'm not doing this, and are just trying to wait us out, because I think that's what some of our students do sometimes. They just sit there and they think, well, if I don't answer it, the teacher's going to call on someone who will have had it answered, and I'll just get told what the answer is then. How many of you tried something, let's say plan A, how many of you have tried something and that didn't work, so you're trying something else now? So you're moving on to plan B. Now, here is my questions that I want you to think about. How did you know plan A wouldn't work? How did plan A not working help you decide on what to do for plan B? And on the other side of the fence, if you tried plan A and it worked, how do you know it worked? So what did you do when you hit stumbling blocks for this? What are the questions you were asking yourself? I think sometimes, and I just want to preface this before opening it up to conversation, sometimes in the classroom, we focus too much on what the solution is, or, and I'm going to talk about this more tomorrow, when we do highlight what the problem-solving strategy is, we just say, what strategy did you use, and why did you use that strategy? And I don't think that's enough, because how many times do we try something and it doesn't work? Then we have to ask, how do you know it didn't work? But even more importantly, how did that experience of plan A not working help you form your plan B? What are some thoughts on that? Do we go deep enough in that? Do we highlight that questioning?
I looked at it from the binary perspective. People agreed that it was impressive. We have Jacqueline, who said that she started through the numbers to see if I could already make each one, and figured out what numbers that she needed. And then Colleen said, I tried a larger number first. So the answers that we got were 1, 2, 4, and 8. Yep.
And we know that that works. So here is my question, and I'm coming back because I know many of your schools are using the 3-part lesson plan. When we're talking about the consolidation, picture you're in the classroom. Well, maybe not today because today is July 30th. Picture you're in the classroom at some point giving this question to your students. And in the consolidation, do we tend to focus on how did you know your strategy worked? How, like, what were some of your aha moments? And if you try something and it didn't work, what were some of the questions you were asking yourself from that? Because it's that self-questioning I think we need to get into. So I'm going to move on to slides, but I just wanted to give you that problem just to kind of get you in the mindset of, oh, solving. Everything I'm taking today is from this lovely book, and I hear great things about this book and even better things about the person that wrote this book. Heard he's a really good guy and a really, really friendly guy, although his wife may not agree all the time. But this resource looks closely at certain characteristics of a literate environment and explores the application of each of these in relation to math. So what I'm taking is the stuff that we already know about literacy and about the literate environment, and we're applying it to math. We don't need to reinvent the wheel. We can leverage those practices that we already know are impactful. And the connection to the classroom. When we talk about questions and questioning in math, what does that mean to you? What do you think of if I asked you, tell me what you think about questions? What does questions mean in your math class? What do you tend to think of?
Just going to read out a point that was made previously, but I think it could answer here as well. Mike said, I agree that we look at product too often before process.
That's it. No, and I think that's a great point. And Mike, you're going to see later in the session that I'm going to give a specific way that we can highlight that process to be more impactful, and that can be used from anywhere from kindergarten through grade 12. Because when I think about questions and questioning, I often have people say, oh, well, we use these type of questions in the classroom. I use questions that would be reflective of the interest of a student, or that are broad enough to have multiple points of entry. And I get something like this. And in many classrooms, teachers use questioning as a means to assess student understanding. Teacher asks a question, students respond, and then the teacher evaluates this response. And while I'm not saying this type of questioning isn't important, I'm really wanting us to move beyond this. I'm wanting us to move beyond using questioning just as a way to collect information from a student. And I know it's important for students to be questioners, but I want to go beyond questioning just as a way for students to collect information from others as well. So what I need is I need students to be active in the math classroom, not just in terms of working with manipulatives and symbols and drawing pictures and talking. We also want students to be questioners. We want students to question their own thinking and questioning the thinking of others. It's not enough for students to just ask what other people are thinking. We want students to make connections between concepts and strategies in a meaningful way. We want students to use questions to strengthen the classroom discussion and then to start an inquiry into certain concepts and ideas. And it's through these points that students will learn to question, to frame their thinking, to support their thinking as they're engaged with the task, and to consolidate their mathematical thinking when they're through there. So this is what we want students to be doing. I will say, and I would like your thoughts, I would say we tend to focus on this. We tend to focus on, we want students to be asking questions. We want students to be asking questions of others, whether that be the teacher or of other students. But do we do this? do we support and highlight and emphasize the importance of students using questions as they're engaged with a mathematical concept or a task? Do we have students relying on questioning as a way to move them forward in framing their experience and their plan of action, and to support that plan and then to consolidate their understanding? I think that we need to kind of go beyond the surface level when it comes to questioning. And I just asked some teachers during this interruption in student learning this year with the whole COVID-19, what are some question types? And here are some of the things that I had as a response. People talked about closed-ended question and open-ended questions. They gave those two distinctive types of questions, whereas closed-ended is a much more prescriptive approach to math, where the teacher kind of knows what he or she wants the students to do and what he or she wants the students to practice. Then we have open-ended questions, which I know you talked about this morning in other sessions. It promotes a less controlled route in that students have flexibility in the approach to apply to solve the question. And then I've been hearing a lot about this in the last few years, multiple choice questions, and like offering 3 to 4 responses that includes a solution, and really crafting other incorrect responses, but that are based on common misconceptions. Then we have the traditional test questions, which we tend to see mostly closed-ended questions, followed by a few open-ended. And then what we are seeing in the classroom, in the actual conversation and the discourse bit, it are these guided questions. And you're not giving hints or solving the problem, but instead you are asking questions to help students make sense of what they're experiencing and to guide them to draw a conclusion. So you're much more of a facilitator instead of a giver of a knowledge, that you're really funneling that through there.
I'm going to cut in there and just make some comments that were made. A lot of discussion about going deeper, similar to what you said earlier. Asking questions to see, talk about the process as we discussed earlier. Good questions that encourage exploration. And talking is a great way to introduce a concept or extend understanding. And then there was a question, this type of questioning of each other as students is somewhat challenging in this teacher school, as class sizes are quite small. For example, just 5 grade 8 students last year. I don't know if you want to speak to a smaller class.
And I think that's very, very fair, because what we need to do, and I'm thinking, and I've had this question from a few other teachers as well, when you have such a small number of students in the classroom, it's much clearer to see which students are not asking questions and which students are the ones asking questions. And it really takes time in building up that classroom culture of risk taking, because that's what asking questions is. It's taking a risk and going through there. And I think what we need to be mindful, which I hope that you take away from this session when I give strategies, is if they're not comfortable asking self-questioning questions, if they're not comfortable asking themselves questions as they're engaged with the work, I don't think you're going to see them ask questions orally in front of their classmates, because crafting the question is a skill set, and then having the confidence and the risk-taking notion to actually voice that in the classroom is a whole nother step. So I think we're going to see some strategies as a way to work through that. So we talked about question types, teacher-directed. Now let's talk about question types, student-directed. So student questioning the teacher during a whole group or small group for the purpose of clarifying information. Within this clarification, students attempt to address any stumbling blocks they may be experiencing or confirm their conjecture of the situation. So that conjecture is kind of like, what are they seeing? Have they seen any trends? And they're starting to kind of see a pattern that they're seeing towards achieving a solution. And then student questioning other students is a way to identify similarities and or differences with peers and to contribute to strengthening the classroom discourse. So I think that gets back to the question of when we have such a small classroom, that one can be much more difficult to massage and to nurture in the classroom. So as a way to address that, what I want to kind of go to is I think we need to dig deeper. I think in terms of questioning, we are going 1 mile wide and 1 inch deep. And we're doing all these different types of questioning because we know the value of being questioners in understanding mathematical concepts and strategies. But I think we need to go 1 inch wide and 1 mile deep. And I think to do that, we need to support students in self-questioning and using this technique to support metacognition. And I think when we support students as self-questioners and as people who engage in metacognition, I think that's when we will see an increase in the questioning within the classroom. And I just want to kind of preface this. So metacognition is the ability to think about our thinking, and it's imperative to the learning process. Marzano called metacognition the engine that drives thinking. So just think about that. So metacognition is the engine that drives student thinking. Garofalo and Lester documented that math instruction without metacognition is inadequate. So those are pretty powerful statements. And then Palinskar outlines 3 parts of metacognition. The first part is that there's an understanding of the oneself as a learner. So you understand how you are as a learner. The second part is that there's an understanding of the task being given and the necessary strategies required to reach a solution. And the third one being the ability to monitor learning and to self-regulate. And what I'm going to ask you is, what are your thoughts on that? Because I know when I've been talking to teachers about this, and I've talked to them in quite a few different areas, and I'll just ask them, we know the importance of metacognition, and I mostly hear about its importance from literacy teachers in terms of reading and in terms of writing. But when I started looking through math resources, while some reference metacognition, is very much at the surface level. There's not a deep digging into metacognition. Has there been much focus or experience with this within the teacher's perspective in this session? So then when we're thinking about metacognition and self-questioning, self-questioning is the metacognitive strategy that allows the learner to monitor their understanding and to identify when their thinking comes off the track. So it's kind of like that self-monitoring when we read. When we're reading something and then all of a sudden, because I know I do it all the time, think, okay, something doesn't make sense. And it could be that you weren't focusing on the text you were reading or that something just didn't jive. You know when you're coming off the track and you work beyond that. And in terms of the importance and the impact of this, because I know during all this COVID time, there's been so many things thrown onto teachers and they've been kind of crafting things as they go. They've been flying the plane as they're building it. And I don't know about you, it'll just be nice to sometimes fly a plane that is completely built without having to build it in the air. But when we look at the work of John Hattie, the following was determined. The effect size for metacognition has an impact factor or an influence factor of 69 hundredths, which is significant, that we know it moves student learning at an influential aspect. And when we think about the effective size for self-questioning, that's at 64 hundredths. which is still hugely impactful. We tend to think of the high range as anything, I think it's like 4,200th and above. So these aspects, the metacognition and the self-questioning, has a great deal of value added to it.
I'll just
And when I was
jump in.
Yeah, definitely.
Yeah. We had Jennifer say, in my own teaching, I never did enough of this work with my students in an intentional way. Just want to say thank you for putting yourself out there.
Well, that's it, Jennifer, and I know myself as well. When I had my own home room, and when I was doing my math groups, I was focusing more on how do I ask more impact questions? How do I ask quality questions as a way to get students responding to questions meaningfully? I really didn't dig deep into this. And I think in terms of what we're going through now with the online learning, or it may be a blended model, or if we're back to face in the fall, I think there's a high degree of self-regulation needed by students as learners. And I think to have this self-regulation, this is where self-questioning can help them be self-directing their own thinking and their own learning with that. And I talked to quite a few people, and I was asking them, what would a self-questioning or an internal monitor look like? What are some of the things you would consider to be that metacognition or that self-questioning as you are engaged with a problem? And here are a few sample things. They talked about examining their calculations to make sure they were relevant, examining how they were actually enacting their plan to see if it doesn't drift too far off course. This one is really interesting. Clarifying between the I know this or this may be right. So just to kind of clarify whether this is something we know for sure or whether we're guessing. Evaluating ideas as they come along in the process, noticing a stumbling block. And I don't know about you, but when you've tried some problems, have you ever had to go back to the beginning stage just to clarify thinking? Have we ever had to kind of work from, well, I tried plan A and plan A doesn't work, so now I'm trying plan B? Reflecting on your own work to identify gaps, or I'm looking outward to see the extensions. And I want you to think about this. Out of this list of 9, which is one of your strengths? Which aspects of this internal monitoring can be one of your strengths? And then on the flip side, which of these 9 points would be one area that you would love to strengthen for yourself?
Oh, there we go. We have a strength from Jacqueline, suggesting an alternate plan. And then her needs work is evaluating ideas as they come along. We have Dwayne saying a strength, known and maybe no. And then a different Jacqueline, if I'm pronouncing everyone's name properly, a strength, reflecting on one's work to identify gaps and or inaccuracies. Kelly, strength, known versus maybes. Mike, for me, I know that I can see the stumbling blocks when they happen, but I have trouble sometimes finding that plan B. Jacqueline, work on evaluating ideas as they come along.
Perfect. And now, here is my question that I would like you to think about is, do we highlight these in the classroom? Do we bring explicit attention to these? Or is this something we assume students do? Because when I see some of these, I see some of these questions only coming out in the consolidation part of the lesson. That there's a misconception that we only do some of this self-questioning at the conclusion of the process. And what I want to kind of argue is that this is something we do throughout the process. This is something we do self-questioning, so that students can make meaning throughout their work with a concept and or strategy. And here would be some work examples. So the one on the right, it's kind of not the most positive problem, but it is a problem nonetheless. This came from a junior high student. So the problem was about Inspector Morris, and I think the teacher grabbed this from the Rich Math site. So there was a murder, a bank robbery, and a car theft. And they had to work towards solving this. And how much would it be for this? And you can see on that problem that the student initially tried something, 2x plus bracket x divided by 2 with a denominator of 3 plus 4 bracket x divided by 2. So the student worked through that and then came to the realization as she was self-monitoring, put stuck. I feel like there is not enough information. So try to go through it again. And then the student put stuck again. I need fewer fractions. So this student reframed the problem and put car theft as the unknown x, and then included what bank robbery and a murder was. And then she went back to the problem and she read the problem backwards. So then doing that, this is how she worked through that. And the problem on the left would be a painting, 15 centimeters by 20 centimeters, is placed in a frame 3 centimeters wide. So the two questions are, what is the area of the painting? And question B, what is the area of the frame painting? So this student solved it. And the 3 little Post-it notes on the side were from other students looking at this work. And they were thinking, okay, well, then what are the questions I would have asked if I was going through this, as a way to strengthen their self-questioning technique. And sometimes it's much more easier for students to identify where they can engage with self-questioning through looking at other works. So here's what I want to give to you. I want to give you another math task. So here it is. My 2-digit number is special because adding the sum of its digits to the product of its digits gives me my original number. What number or numbers could it be? So I have a 2-digit number and it's special because when I add its 2 digits together with the product of its 2 digits, it gives me my original number. What number or numbers could it be? So I want you to try to work through this and to solve this. And when you're working through this and solving this, I want you to focus in on thinking about your own thinking. What are some questions you need to ask yourself? What are some questions you need to ask to help you move forward in regards to your thinking?
As they're working away, we did have a comment on the previous slide that just said,
Yeah.
I love the notes, 2 different pieces. He drew a picture that was helpful. I didn't do that. And then the other piece was the word stuck. So Jennifer loved those 2 notes that the students wrote.
That's it. And what I've done in the past is in my classes, and I've done this regardless of their age, is I've had them use a strategy called margin notes. And it's something that they're used to doing when they read. In that if they're reading a text, they'll either put a little symbol for when they have a question or when they make a connection, or they can write on a little Post-it note a connection they made, a question they have, or a stumbling block, or an aha moment. And that was kind of like what their thinking footprints are as they were engaged with the text. We do the same thing with math. I have my students regularly use 3 prompts. The word aha. If they have an aha moment in their work, they would write aha beside it, and just a few words under aha of what their aha moment was. Something else they can write is the word stuck if they hit a stumbling block, but they have to tell me in a point form, a few words, what they are stuck on. And the other one is a question mark. When they're going through the work, when they have a question, they can then record that question underneath their question mark, and then I can use that to help me formatively assess and to help decide on what next steps are. And we got to the point using Google Docs. If I have a work sample, I will have them go into the comment and just add a comment in Google Doc, putting a share, either an aha, stumbling block, or a question mark. So it keeps that conversation going in the online setting. So what are some questions you would have had during this, during attempting to solve this problem?
I have some responses.
Okay.
Do you want those, or do you want them to answer?
Yeah, definitely.
Yep. Okay, so we have Dwayne said 19. Mike said any 2-digit number that ends in 9, solved algebraically. Jennifer said 29. Mike said 10 times. Jen said, agreed, Mike, any 2-digit number ending in 9. Mike did his algebra there. 10x plus y equals x plus y plus xy. 9x equals xy. And Jacqueline, I did the same way as Mike. And then Mike finalizing his response, therefore, y equals x. Or y equals 9, sorry.
Okay, so then here we go. So when you were working through this, did anybody hit any stumbling blocks?
It's Mike here. I started for a few seconds trying to do some trial and error, and I realized very quickly that that was going to take too long. So then I just looked at the numbers a little bit more closely, and the algebra just sort of, I wish I could say how, but popped into my head, and I saw it and went from there.
Okay, perfect. So, Mike, so then what I am taking from this is that when you read the problem, you initially thought of plan A, trial and trial and error. But then when you were thinking more about that plan, you put that plan to the side, and then you went to plan B, which is solving it algebraically. So my question would be, in terms of self-questioning and in terms of metacognition, do we tend to spend the time on that in the classroom as those internal questions, those self-questioning and the internal monitoring? Do we spend time on that? Because sometimes when I give tasks like this in the classroom, my learning goal isn't that you solve the problem. It's great if you do. But I don't know about you, but in my classroom, I would have quite a few students that might not even try to come up with a plan A. Or if they have a plan A, and if plan A doesn't work, they might just kind of put their pencil down and retreat from the problem. So my goal is, if you try something and it doesn't work, what did you do next? And if you try something next, that plan B, that is success. That is what the learning goal is. So I just want you to stop and think, do we do enough of that in the classrooms?
One of the Jacquelines stated, I did the algebra, and when one method got eliminated, I abandoned that method. I tried other things and then realized that I was right the first time and went back to it. Love that.
Well, okay. So then that's great, because right now, think about if you did that as a think aloud in the classroom. Think about the power in that student a student recognizing that the teacher can try something and then come back to it. Because how many of the students in the classroom think being a strong mathematician is when you have success trying plan A? And that's not success. Success is being able to work through it to understand and to make a meaning. And that gets me to what my next slide is that Jansen stressed that self-questioning needs to be explicitly taught in the classroom. We need to foster the skill of self-questioning in students by creating an environment that promotes and values self-questioning, modeling self-questioning for students, and providing opportunities for students to receive feedback on their use of their self-questioning. So, and students need to be aware of the purpose of asking these questions. It's to clarify their thinking when engaged with the problem to move forward. And the tricky thing is when students are not able to generate these questions, it becomes difficult for them to identify what their next step is. How many times do we have students saying, I don't know what to do, and they rely on you to tell them what the next step is? But they need to be able to use questioning as a way to move their thinking forward. Because if we're waiting for the teacher to give them a prompt of what to do next, then that's really not active learning for the students. That's more of a passive learning. And that takes me here in that when students self-question during the problem-solving process, they are able to support themselves as they work through any stumbling blocks. But sometimes we need to provide support into, and like Jansen said, into developing these self-questioning skills. So what I'm going to show you are two anchor charts that I've used before. And these charts were interactive, that they were kind of tweaked as we went on. It just wasn't something crafted by the teacher, but it was something crafted in collaboration with the teacher and a student, and they built it together. Let's look with the one on the right first. These were the two questions that the students heard most. What can I do? Or can you help me? That's really not students being active learners. So what that teacher did is kind of showed, if you have a what do I do question, here is a sample that came from the class of a quality question. I'm not sure how to find the missing dimension when I'm given the area and length. Is it still using the same formulas and I just put the values in I know? So that would be an example of a student using self-questioning. The other one, can you help me? So the students came up with, I use partial product strategy for multiplication, but I forget how to check to see if it makes sense. Can I use another strategy to get the same answer? And then this one, which I've used quite a bit, is kind of a two-column chart. So these are the prompts right here. What I'm thinking, if the student thinks, I don't know where to start, here are some questions the student can ask themselves as a way to help them getting out of that stumbling block. If the student is in the stumbling block of this isn't working or my strategy isn't working, these are two questions they can ask themselves to help get out of that stumbling block. Or this one, this doesn't make sense. Here are some questions. Or I need more information. Or I'm unsure of how to proceed. Or I think I am finished. Instead of having those stumbling blocks as prompts, we can look to the right side and see these self-question stems that can put the learning back onto the student instead of the teacher doing it. What are your thoughts? Can you see using that? I will say this chart here is very, very helpful, but I find the chart on the left as an anchor chart in the classroom to have moved student questioning, self-questioning, and learning forward quite a bit.
I'll share what Mike has. I like to start my students with 3 questions. What do you know? What do you need to find out, and how can you get there?
Yeah, and are those the questions that they ask themselves as they're engaged with the learning?
I try to model that behavior early in the year, where as we're doing some problem solving, I'll take them through that. What do you know? What do you need to find out? And talk through some strategies on how to get there, until it becomes ingrained in them that that is sort of that initial process of getting going. And then they start thinking more and more about that third part. How can I get from point A to point B?
Perfect.
We have, just before you respond, we have Jacqueline as well, who said, my students are always saying I need help or I don't get it. I'm always asking them to be more specific about what they are, where they are struggling. These questions would help a lot.
Yeah, definitely. And I know in the classroom, in my classroom, whenever someone would think of another question, we would just add that to the right side of the column, saying these are questions that we can work through. And the great thing about this, and I come back to this because I know it is in people's mind, if we have it online, think about the support that a chart like this could be for parents and families at home supporting their children, working with this, that as a way to support student self-questioning, parents can be asking, or families can be asking these questions to students when they hit stumbling blocks. And these are just some of the charts that I just took from my work here, just because I know that they have quite a bit of value added in that. So as a way to wrap up, I want you to think about, this is something we do in literacy all the time, that we've crafted a spot, and when we talked about process and product at the beginning, think about how in terms of the writing process, the product is the process. And we have the 5 stages within the writing process. The pre-writing, which is like the brainstorming, the planning. Then you're drafting, where you're just putting everything down onto paper. Then we revise, get rid of some ideas we don't want, or include other ideas, or to rearrange concepts. And then we edit, when we make those minor corrections, whether it be in structure, grammar, spelling, and then we publish a copy. We don't go straight from the planning to the to the publish. Instead, we go all around this process, and we value their thinking all in these different steps right here, because we want to see what the journey is and how their thinking has evolved over time. What I want to ask in terms of math, how many times do we go from the planning right to the publishing? And an example of this is when we allow students to erase their work all the time, when we lose what their thinking points are, and when they've made any alterations to their plan, and we lose that. So are we valuing all this process in math, or do we just go from the pre-write to the publishing? And then here would be an example of those 5 processes, of those 5 stages in the writing process, and what it would look like in terms of a math. And I'm just wondering, in math, how many times do we focus on getting the students to choose a strategy, and we ask them why they choose the strategy? Then we get them to write. But notice how I'm not highlighting a rough draft, because what they submit is a good copy. And we talk about how that they need to have it neatly done, and we need to clearly see what their thinking is. But we're not clearly seeing what their thinking is, because anytime we allow them to erase part of their work, we are removing what their thinking tracks are. within this. Going back, and I'm just going to go back to a slide here, going back to this slide to the work samples on the inspector remorse problem, if we didn't value what their thinking is, we would not have any of this work right here. We would not have any of that whatsoever. We would just go to their good copy right here and think of all of the thinking that we miss. So sometimes when we're self-questioning, we need to provide the structure for that and the process for that. And we can do this in math quite a bit. And instead of using writing to demonstrate what your knowledge is, why don't we use writing to learn? And that's an approach that involves short, informal written pieces that allow students to clarify what their stumbling blocks is. And it makes student thinking visible for both the students so that they can learn from it and they can see how their thinking evolved. But it's also great when we make student thinking visible for the teacher so that we can clearly understand what the thinking of students are for an assessment and planning purpose. And examples of writing to learn activities could be journals, learning logs, free writing notes. And I just wanted to kind of highlight this. Writing to learn acts as a metacognitive strategy as students work through the concept. It's meant to provide students opportunity to explore both their thinking and the concept. And I think we're almost there, people. Thank you for staying. So what are some of the next steps? These are just some of the many strategies I just took from my book. Modeling self-questioning as a teacher when working through a task. So you can do that as a think aloud, or you can have students model their self-questioning that they work through the task. That could be a consolidation activity right there. You could use student work samples to highlight opportunities for self-questioning. An example could be when I showed you earlier about the problem involving the painting and finding what the area of the painting itself was and then the area of the painting within the frame, and highlight opportunities for when we could self-questioning. Have students refer back to an uncompleted work sample and to highlight any questions they now have about their own work as they look through their work. Maintain a question board in the classroom to highlight student self-questioning questions. And in terms of online learning or blended learning, you could do that as a Google Doc where you could put something up and then students could include some of the questions they ask themselves as they work through. And then, yeah, these strategies are taken from my book. And there's my contact info if you have any questions.